Hello my friends. My name is Stefan. I'm a voice generated by AI, and together with my AI assistant Eva, we'll take you on a deep dive into how LLM modules work. So, let's begin. Pre-training, data collection and curation. In this episode, we'll take a deep dive into the pre-training stage, the foundation from which the entire model grows. The first and most important step in building a language model like GPT. The journey of building a large language model, LLM, begins with pre-training, a crucial phase where the model learns the structure, patterns, and nuances of human language from vast textual data. This phase lays the foundation for the model's linguistic understanding and general knowledge. Most modern LLMs, such as those developed by OpenAI, Anthropic, and Meta, leverage massive datasets sourced from the open web. An example of a high-quality dataset is Hugging Face's FineWeb, a 44 terabytes curated dataset built from public web content. So what we are trying to achieve here? We are trying to get ton of text from the internet from public sources, so a huge quantity of a high quantity and diversity documents. Achieving this quite complicated, and as you will see it take multiple stages to do it well. Why 44 terabytes? While the internet contains many petabytes of data, FineWeb's relatively smaller size reflects aggressive filtering for quality. Raw web data, like that from Common Crawl, is often noisy, redundant, or low value. Curation ensures a high signal-to-noise ratio by prioritizing diverse, information-rich content. Now, my friend Eva will guide you through and explain what Hugging Face is, as well as what Common Crawl means.
Hey Steven! Thank you for your introduction. Hugging Face is like GitHub for AI models. It's a hub for open-source machine learning models, datasets, and tools. It hosts thousands of models, everything from text classification and image generation to speech recognition and translation. You name it. You'll find popular models like BERT, GPT-2, and newer ones like Mistral, Falcon, Llama, and more. The best part? You can try many of them directly in your browser. I highly recommend it to anyone passionate about machine learning, and especially large language models, LLMs.
A cornerstone of many LLM datasets is Common Crawl, a nonprofit project that regularly crawls the web and offers petabytes of open data. However, only a small, filtered portion is typically used, as the raw HTML contains everything from high-quality articles to broken pages and spam. So, let's begin with the actual steps. We'll combine Title 1 and Title 2 into a single title. URL filtering and text extraction. To improve data quality and ensure ethical use, multiple layers of filtering are applied. Exclusion lists. Domains associated with spam, disinformation, explicit content, or malicious software are blacklisted. Data provenance. Respect for intellectual property and privacy requires the exclusion of paywalled content, user-generated private data, content with legal or ethical restrictions. 3. Language filtering. Language classifiers are applied to retain only content matching the target languages. For example, FineWeb filters for documents with at least 65% English content. This filtering impacts multilingual performance. An English-dominant dataset improves English fluency but can lead to underperformance in other languages. Projects like Bloom explicitly focus on multilingual balance, so I think it's very clear and doesn't need any comments from my friend. 4. Gopher Filtering. This step is named after DeepMind's Gopher model, and it's used to filter out low-quality or irrelevant content based on criteria like coherence, topic relevance, formatting, etc. Essentially, it's like a quality control filter, keeping only web pages that contain meaningful, structured, and valuable text. Let's hear what you have from your side, Eva.
Thank you, Steven. Absolutely. Let's break down Gopher filtering with a clear example. Let's say we have these two text samples scraped from the internet. Text sample A, LOL, 2 laughing emojis. Check out this website for free money. Click now. Money signs. Text sample B, the theory of general relativity, proposed by Albert Einstein in 1915, revolutionized our understanding of gravity by describing it as a geometric property of space and time. So, what would Gopher filtering do here? Text sample A would be discarded because it contains too many emojis, spammy clickbait language, and provides no educational or linguistic value. Text sample B would be retained because it's informative, fact-based, uses well-structured language, and is suitable for model training. As we can see, the filtering criteria used in Gopher include things like text length, language detection, content scoring, and more. So now you can probably understand why Gopher filtering matters, even without reading all this explanation, right? Honestly, I think each of us could use a little Gopher filtering in our lives. Winking face, thanks again, Steven.
5. MinHash Deduplication. After filtering for quality, the system uses MinHash, a technique from the field of data mining, to remove duplicate or near-duplicate documents. This is important because training on repeated or overly similar content can cause the model to overfit or memorize, instead of learning general patterns. Think of this like decluttering the training set, keeping unique ideas while removing copies. Go ahead, Eva, take it from here and explain to us what the MinHash filter is.
Sure. Here's a simple and clear example of MinHash Deduplication, which is used to detect and remove near-duplicate documents or web pages, especially in large-scale datasets like Common Crawl. Let's say you have the following two sentences. Document A: Artificial intelligence is transforming the world of technology. Document B: The world of technology is being transformed by artificial intelligence. These two sentences express the same idea but with different word order. A traditional hash function would treat them as completely different. MinHash, however, helps us detect that they are nearly duplicates. As a result, MinHash recognizes the high similarity between the two and can mark one for removal or merging, effectively reducing redundancy in large datasets. There's a lot more detail about how it works, but for now, let's stop here.
Okay, thank you. 6. C4 filters. This is based on the colossal clean-crawled corpus, C4. Originally created by Google for T5, the C4 filters apply strict rules to clean web text, remove boilerplate content, like NAV bars, ads, eliminate non-natural language content, strip out pages that are too short, too long, or in non-target languages. Passing the mic to you, Eva, let's hear it.
Let's say we crawl 2 web pages and extract the following raw content. Web page 1, before filtering, the following code. Web page 2, before filtering, the following code. The first step is HTML stripping, which involves removing all HTML tags, JavaScript, and other non-content elements. The second step is language detection, for example, keeping only English or another desired language. The third step is heuristics filtering, which includes things like discarding pages with very short text, a high proportion of non-standard characters, and other low-quality signals. As a result, Web page 1 is removed due to spammy content, promotional phrases, and little educational value. Web page 2 is retained. To conclude, the purpose of the C4 filter is to ensure that only high-quality, informative, and clean web text is used to train language models, avoiding junk, spam, or misleading data.
Thanks again. Okay, let's move forward. 7. Custom filters. These are handcrafted rules or ML-based classifiers tailored for the specific LLM project. Examples: removing hate speech or adult content, excluding certain domains, e. social media, emphasizing underrepresented topics or languages. This step makes the dataset more aligned with the goals and values of the model developers, so I think it's very clear and doesn't need any comments from Eva. 8. PII Removal. Finally, the system scans the clean dataset for personally identifiable information, PI, like names, emails, phone numbers, credit cards, and removes or anonymizes them. This step ensures privacy protection, compliance with data protection regulations, more responsible AI development, so I think it's very clear and doesn't need any further explanation. Let's recap the key points discussed in this episode. We explored the concept of sourcing public web data, starting with an overview of Common Crawl as the foundational raw dataset. We then delved into key pre-processing steps, including URL filtering and text extraction, language filtering to ensure content quality, MinHash deduplication for eliminating near-duplicate content, the use of C4 filters, and the application of custom filters for tailored data refinement. These steps collectively form a crucial pipeline for preparing high-quality web data for downstream applications. In our upcoming episode, we'll dive into the fascinating world of tokenization, a key process in how language models understand and process text. We'll break down what tokenization means, how it works, and why it's so important in the journey from raw data to intelligent responses. Stay tuned, and thank you for watching.